Hello students, today we will see the time response specifications of second order system. So actually we have derived output response derivation in last lecture. So today we will see the transient response specifications of second order system. Okay. So actually we have to derive the derivations related to all these terms. So first of all, we will see what are exactly these terms. We will understand the concept behind these terms, then we will derive. So look at this. Transient response specification of second order system. Okay. See, this response is called as underdamped response. Now we are familiar with this response. Okay. So see the term related with this. On y-axis I have shown C of t and on x-axis this is time t. Okay. So here 6 definitions are given. We will start with one by one. First of all, delay time td. Okay. So look at the term. Delay time td. The delay time is the time required for the response to reach 50% of final value in first time. Okay. Please understand, here it is given that first time. First time means first peak overshoot. You can see that this is the transient response. We have seen that the output response is divided in two parts. Number one, transient response, and number two is steady state response. So here we are getting transients. So we are discussing about the first peak overshoot, that is first peak. So here it is written that first time. Okay. So look at this. The first definition, delay time td, is the time required for the response to reach 50%. Look at this. This is 50% of final value. So this is the time. Okay. So this time is represented where td. Okay. So this is called delay time td. Now second definition, rise time tr. Okay. So it is the time required for the response to rise from 10 to 90% of its final value for overdamped system and for underdamped system 0 to 100%. See, we have seen that when zeta is greater than 1, then that system is called as overdamped system. When zeta is in the range of 0 to 1, then that system is called as underdamped system. So we will discuss about the underdamped system. Okay. So look at this. When the time required for the response to reach to 100% of the final value. Look at this. This is output response. So time required to reach 100%. So look at this. Time required to reach 100%. So this is the point. And I will show this with. Okay. So this is rise time tr. Okay. So first of all, we have seen time required for the response to reach 50% of the final value is called delay time td. Time required to reach 100% of the response is called rise time tr. Now we will see the third definition, peak time tp. Look at this. So the definition is the peak time is the time required for the response to reach the first peak of time response or first peak overshoot. Okay, see the term overshoot. You can see that here in transient response, this is the highest peak or maximum peak. Okay, so what is given here? Time required for the response to reach the maximum value. You can see here C of t is maximum. So time related or time required for the response to reach the maximum value is called peak time Tp. So this is the term peak time Tp. Okay. Now next, number 4, maximum peak overshoot. Okay. So it is the normalized difference between the peak time of response and steady state output. Okay. And steady state output. So here definition is given. Percent MP, this peak overshoot is denoted with MP. So percent MP is C of Tp minus C of infinity. Okay. So we will see C of Tp, this is the peak or the output when we are getting the peak time Tp. Okay. And next is C of infinity. So look at this. What is C of infinity? When the transient will die out and steady state will start. So this is the time you can see that the transient will die out. Okay, so peak overshoot is given with the normalized difference, this one. So normalized difference between Ct of, look at this, Ct max means nothing but C of Tp minus C of infinity, okay, is called as peak overshoot MP, and the percent peak overshoot is given by C of Tp minus C of infinity upon C of infinity into 100. So for example, when I am saying C of infinity, so this will be the steady state value when time reaches to infinity. In that case, the value of C of infinity, it will be 1. You can say this will be 1. Okay, so whatever C of Tp we are getting, okay, so minus 1 upon 1 into 100, that will be the percent overshoot. Okay, now next we will see settling time Ts. So what is definition of settling time Ts? The settling time is the time required for the response to reach and stay within specified range 2 to 5% of its final value. Okay, see here, just now I told you that at this instant transient will die out and steady state will start. Okay, so you can see that this output response is following some reference value. Okay, but this response is not on this line. Okay, there is some difference. So this difference is generally 2 to 5%. Okay, this difference is generally 2 to 5%. So again I will repeat the definition. The settling time is the time required for the response to reach and stay within specified range of its final value. So this is specified range 2 to 5%. And what is settling time? You can check that. See here peak overshoot or transient will die out at this instant and steady state will start. Okay, so this is the time that is called as settling time Ts. Okay, now the last definition is steady state error. What is steady state error? It is the difference between the actual output and desired output as time t tends to infinity. Okay, again I am repeating, look at this, this is the difference. Okay, it is the difference between the actual output. What is actual output? This is our actual output denoted with blue line. Okay, actual output, and desired output, this is the reference, that is desired output. Okay, so difference between this is given with the steady state error. See, while deriving the output response of first order system, we have used this formula, that is E of t is equal to, what is E of t? E of t is nothing but difference of input minus output. So that is nothing but E of t is equal to R of t minus C of t. Okay, so I have given this formula for steady state error. ESS is equal to limit t tends to infinity R of t minus C of t. Okay, so see, in next class actually we have to derive the expression for TD, TR, TP, MP, TS and steady state error with the help of the basic equation that we have derived, that is output response for second order system with unit step input. Okay, so in next class we will derive all these expressions related with these specifications. Okay, so thank you students.